Welcome to Corporate Finance. In session number 6, we're going to look at individual incremental cash flows and discount them or back to today or compound them out to the future. So future value and present value of multiple cash flows. In session 5, we dealt with one large lump sum cash flow. Now in session 6, we're going to deal with valuing multiple cash flows. We're going to look at a concept known as annuity. What is an annuity? Same amount each month, same amount each year. An example of an annuity in your life might be your rent. You pay the same amount each month. That one in particular is called an annuity due if it's due on the first of the month. Then we'll look at perpetuities. What is an annuity that goes on forever? So you see the word forever, you want to think of perpetuity. What is the present value of a perpetuity? C over R. Then we're going to look at EAR, EAR, effective annual rate, and compounding. How much are you really paying on that 18% credit card that's in your wallet? Banks are only required by law to state you the APR, and they may say in the tiny print, compounded monthly. So if you have an 18% credit card compounded monthly, you're really paying about 19.56%. So we want to understand what that EAR concept is to see what we're really paying on our credit cards or what we will be paid if a bank promises you 10% compounded daily or 5% compounded daily. How is that different than the EAR? Finally, we'll look at three different loan types and loan amortization. Pure discount loan, like a treasury bill, a corporate bond, which is an interest-only loan, and then an amortized loan, which is like your home mortgage. We'll discuss all these loan types and loan amortization in this session, session 6, discounted cash flow valuation. Present value of an annuity, PVA equals C times 1 minus 1 over 1 plus R of the T, all of that over R. This is the mortgage equation. This is the car loan equation. This is the student loan equation. This is the credit card equation. So this is the one you want for all those purposes. So once you learn this annuity formula, you should go into the bank, should be able to go into the bank knowing what your car payment will be, knowing what your mortgage payment will be. And that will be that C variable in that equation. Then we can move on to future value of an annuity. Can I invest something smaller than $15,091 in a big lump sum like we did in session 5? Because I don't have that kind of money. Can I invest a smaller amount each year, same amount each year, and still become a millionaire? To do this, we will use the future value annuity because we're going out to the right on the timeline. Present value annuity is bringing it back to today. When am I going into the bank or a home loan or a car loan? Today. So that's present value of an annuity. How much money will I have in 20 years? That's future value of an annuity if I invest the same amount each year. Present value of a perpetuity. What if that annuity goes on forever? What will it be worth? Very simply, C over R. And that derives off the equation above it, where T goes to a very large number, like 100,000 or 200,000 or a million. And I'm left with PV equal of perpetuity equals C times 1 over R, because 1 over 1 plus R T goes to a very small number. And finally, EAR. What is the effective annual rate? And you'll use this when you see the words compounded blank. So if a bank quotes you a rate and they say it's compounded monthly, compounded quarterly, compounded daily, you're going to receive more or you're going to pay more. If you have a 18% credit card in your wallet and on the back of your credit card bill it says compounded monthly, you'll be paying much, much more than 18%. So we'll go through that and calculate some of those effective annual rates. First learning objective, present value and future value of multiple cash flows. And these will be different cash flows, not the same cash flow, so not an annuity. So we're back almost at chapter 5, looking at different individual cash flows. 2 ways to calculate future value with multiple cash flows: compound the accumulated balance forward one period at a time, or calculate the future value of each cash flow and add them up. And I think I like method number 2 best. You think you can deposit $4,000 at the end of each of the next 3 years into a bank account that already has $7,000 in it today, You can earn 8% interest. How much will you have in 3 years? How much will you have in 4 years? Now on chapters 6 through 11, I'll recommend that you always create a timeline. So here's a timeline, T0 today being on the left and T4 in this case being all the way out to the right. $7,000 is in the bank today at time 0, and each year we're going to deposit $4,000 on December 31st. That's what these authors assume, that these monies get deposited at the end of each year. So how much will I have at the end of year 1? The $7,000 will grow to $7,560, and then I'll deposit that $4,000, which will gain no interest, so I'll be sitting there with $11,560 at the end of year 1. That will gain 8%, and that will be worth $12,484.80, and then I drop in the next $4,000 at the end of year 2, and I'm there with $16,484.80. Multiply that by 1.08, and I get $17,803.58. And I drop in again the $4,000 with no interest because it comes in on December 31st. And I'm sitting there with $21,803.58 at the end of year number 3. And then at the end of year 4, there is no additional deposit, but it still gains the 8% interest. And I'm sitting there now at the end of 4 years with $23,547.87. So again, you can see very practical use of these future value, present value equation that we learned back in chapter 5. Now I can also calculate the present value of multiple cash flows, discount the balance back one period at a time to time 0, or calculate the present value of each cash flow and add them up. Keyword being today. Whenever we're looking for present value, we're looking for today. You're offered an investment. Here's an example that will pay you $200 in 1 year, $400 in the second year, and $600 in the third year, and $800 at the end of the fourth year. You can earn 12% on similar investments. How much should you pay for this opportunity today? Again, draw yourself a timeline. That first $200 is only worth $178.57 today. Note that these are differing cash flows, so we have to go back to chapter 5 to bring these back to today. The $400 divided by 1.12 squared is equal to only $318.88. $600 divided by 1.12 cubed is $427.07, and the $800 way out there in year 4, divide that by 1.12 to the fourth, and it's only worth $508.41. Sum these all up, and I get a total present value of those 4 cash flows of $1432.93. Assume in all cases when we're doing these problems that these cash flows arrive at the end of each period. So this would be December 31st of year 1, we'll get $100. December 31st of year 2, $200, and December 31st at the end of year 3, $300.